Hey guys, I'm going to go through actually 4 examples of the homework. I'm going to do g of x, p of x, and then I'm going to do the bottom problem on compounded interest, and then I'm going to do one from the back. So that's going to have to be a separate video because it's on a different page. So normally I won't do this many, but tonight I just got to different points with different classes, so we're going to do 4. Okay. If we're going to find the inverse function of g of x, the first thing we're going to have to do is call g of xy. And many of you got to this point already. So now we have y equals 1/2 to the 2x. And the next step is pretty straightforward as well, so I'll just skip that. And now we have to solve for y. So since we have a positive base, and we don't have anything else like something we're dividing by, multiplying by, adding or subtracting, we can use our logarithm to get that exponent to be all by itself. And since the goal is to get that exponent alone, that's definitely going to be the only thing on that side. On this side, you have to create a logarithm because you are moving that base to the other side of the equation. So log base 1/2 of x. And you can put that in parentheses or not. It's just a term by itself, so you don't need the parentheses. And to get the y by itself, the last thing you need to do is divide both sides by 2. So in the end, you're not going to tell me about y, you're going to tell me about g inverse of x, which is log base 1/2 of x over 2. Pretty straightforward example. Now let's do p of x. P of x is a little trickier, so let me just brush through those initial steps pretty quickly. And now our goal is to get y to be by itself. So the first thing we have to get rid of is this 1/2. And the way that we're going to choose to do that is by multiplying both sides by 2. The reason that works is because if I do 2 times 1/2, that's 1. So essentially, those two things cancel. And on this side, you're left with 2x. On this side, you're left with just log base 9 of 3y plus 1. Now you have to get rid of that logarithm because all you're left with is the logarithm. There's nothing else around here that we can get rid of. So in order to do that, we're really asking ourselves the question, to what power, which is 2x is the power, must you raise 9 to equal 3y plus 1? You know that the only thing that's going to be left on this side is your 3y plus 1, and on this side you're going to have 9 to the 2x power. After that, you just have to get y by itself. So you're going to subtract the 1, you're going to divide by 3, so you're going to end up with p inverse of x equals 9 to the 2x minus 1 over 3. And that's your inverse function. Okay, let's move on to the growth and decay problems. I'm going to do this first example because I don't think we got to finish it in any of the classes. So we'll start off by reading it. Henry has an account at the bank that accumulates 5% interest compounded semi-annually. So those are some words that we need to recognize. Those affect the type of formula we're going to use. If he initially invests $345, how long will it take him to have $500? So we got a bunch of different components here. We've got A, we've got P. We know we're compounding our interest, so we're going to divide our rate by how often we're compounding it, and we're going to multiply our time by how often we're compounding our interest as well. Well, he's gaining money, so he's going to start with less than he ends up with. Right now, or initially, he invests $345, so that's P. We're wondering how long it's going to take him to increase that $345 to become $500. Our rate is 5% or 0.05, and we're compounding semi-annually, which means we're dividing that rate by 2. And that means we're multiplying our time by 2 as well. At this point, we're just solving a regular old equation, and the first step is pretty easy for us. All we have to do is divide both sides by 345. And here you can see that I've divided both sides by 345 and also taken the liberty of reducing this fraction. The reason I didn't evaluate it is because I would have to round because I would get a repeating decimal, or not a repeating decimal, but a decimal that doesn't Doesn't end on the screen anyway, so I would have to round. And I don't want to round now because I'm in the middle of my problem. Now all we have is a positive base and an exponent, which we want to get by itself. So we're going to get that exponent by itself. So we're going to have a 2t over here. But in order to move that base, we need to use a logarithm. So that 1.025 is your base, and 169ths is what we are going to use as our argument. And that's what we call this piece right here. Lastly, we have to get time by itself. So we clearly need to divide both sides by 2. So time in this case is going to equal log base 1.025 of 169ths divided by 2. And you just need to punch that right into the calculator. You should get 7.51 after we round, and that's okay now because we're at the end of this. And we need to make sure that we use our units. So since our interest is an annual rate, this is going to be years. All right, and I will do one more short video on one of the examples on the back of the homework.